Hey guys, this is Mr. Sal. We're going to look at the Module 6 overview for integers, going through each section individually and all the problems. Just remember that this terms and concepts, we're looking at absolute values, positives, negatives, and then the four operations with the integers. Now this is a review, so we do expect you guys to know how to do these pretty well from by now, but we'll do a little bit of explanation. If you need more information, just go to each of the sections for this unit and each of those lessons, each of the ones that you need anyways, and look those over. Alright, so absolute values are asking how far from 0. So if I'm asking how far away from 0, -7 is, hopefully you would say 7, right? Because we don't usually look at how far in terms of negatives. So none of these answers should be negative, at least the absolute value part of it, right? So this first one is 7, but the next one shows the absolute value of -8. And first I would show that as 8, right? And that was asking how far away -8 is from 0, which is 8. But then it's got the negative, so it's the negative absolute value, which means the answer is simply negative. So these two would be the first two answers for this problem. Now these next two want a number line, so we'll go ahead and make our own right here. So there's a nice number line. They're both negative, so I'm just going to put 0 right there. 1, 2, 3, 4, and 5 would be right there. And going into the negatives, -1, 2, -3, -4. There's -5. And that's really as far as I need to go. I mean, you could go further just depending on how big your line was, like mine. But it's not necessary to show all of those, okay? So the first value that I have here is this -3. And it would be from 0, would start at 0, then would go -1, -2, -3, right there. So all I'm going to do is put a point, and since it is one of the values we're looking for, I'll just put it on there as -3. Now -5 is already shown. It's already labeled just because I usually label these in every fifth one. So that's it. That's as far as we would need to go on this problem. Alright, for this next set, put a greater than or less than or equal sign to make the statement true. So when we're comparing numbers, especially with greater than or less than, we're just looking at the number line and seeing which one is farthest to the left on the number line. So we'd have to look at 0 in the middle like this, right? Now 19 would be to the right of 0. And -23 would be to the left of 0. Now remember, the numbers farther to the right are always the bigger ones, which means that it should be eating the bigger number, which in this case is 19. Now next up I got -14, which, I mean, it doesn't have to be proportional, but somewhere like this, right? -19 is to the left of that because it's a bigger negative. So since -14 is farther to the right, this also eats the -14. Next up, we'll represent the English statement with signed numbers. Okay. You can label these if you want, but it's not required. Jim lost 27 pounds last week, so we know it's 27, right, on this one. But since it was lost, it's going to show as a negative value. Now, Rick spent $92 from his checking account. So we know it's 92, that's fine, but since it was spent, it would be a negative also. And again, if you want to label these, that's fine. It's not really necessary, right? Like you could put pounds and you could put dollars, and that's okay. Alright, next up, we'll look at adding these integers using tiles first. So for part A, again, my positive tiles are going to be in black and the negative ones in red. So to start off, I've got 4 of these positive tiles, and then I got 7 of these negative tiles. So I've counted those out, and again, I'm going to show the work even on this because, and I'm going to use the same colors we use in the unit, but each of these are going to be 0 pairs. A red one is going to cancel out a black one as a 0 pair. So what do we have left is these three, which would represent -3 right there. Now we'll use the tiles. The counters is what that really is. The next one as well. So here's my circle first of all. And again, I got my negative counters, which is this 5 negative ones. 1, 2, 3, 4, 5 negatives. And then the black ones are positives. And in this case, there's 3 of these black ones. So again, I'm going to use blue to show my 0 pairs on this. So there's a 0 pair, there's a 0 pair, and there is a 0 pair. So I've got 2 red counters left, which total value would be -2. And of course, from this unit, after we used the counters, we used number lines on this. So let's go ahead and look at number lines for adding these values. And remember, for me, the first number tells me where to start, right? So I need to start at 4 on this one. So I'm going to put 0 here. 1, 2, 3, 4. There's 4 right there. So I'm going to start at 4 with red to show that I'm starting there. And since it's adding a negative, this means that I would actually go to the left 7 spot. So from -4, there's 1, 2, 3, 4, 5, 6, 7. So there we go. And what value is that? 0, -1, -2, -3. So we ended at -3, which means that that is our final answer. So using a number line for this next one, again, the first number tells us where we should start. And in this case, we're starting at -5. So there's 0, -1, -2, -3, -4, -5. So that's where we're starting right here. And the addition tells us to go to the right, because we are adding a positive here. To the right 3 spaces. So from -5, we're going to go to the right 3. 1, 2, 3. And what value is this? That is at -2. So the answer to this one is -2. So when we're adding integers like these, again, the first thing we need to consider is which is there more of? Is there more positives or negatives? And whichever one there is more of, that is the sign of the answer. After that, we just subtract the big number and the small number, okay? So on A, I know that there's more negatives, so I know my answer is negative. And then I do 7 minus 4, which is 3. So I make this a -3 on this one. And for B, again, I know there's a lot more negatives in this one, so I got a negative answer. Then I take the big number, 298. I subtract the 17. And this would be my final answer. 8 minus 7 is 1. 9 minus 1 is 8. And then the 2 just drops. So the final answer on this one was 281. Now on this third one, the 2 signs are the same. And we are adding these together, so I know the answer is negative. But since we're adding the same signs, we're actually going to add the 2 numbers together as well. 15 plus, sorry, let me get that, plus, there we go, plus 9, which would be 24. Now the answer is not that positive 24, it's this negative 24, because we knew the sign was negative in the beginning. Alright, again, number 8, just say to use tiles, so what the heck, here we go. But I may change these, right? Just so it kind of makes a little bit more sense for us. And for this particular section, if I remember right, it was easier for us to look at this as, just to start off, as -3, but we're going to add this as -4 instead. And the second one would be 5, and we'd be adding a -9. This just may help us to look at this type of diagram with the counters a little bit better. So for part A, we're going to start with the 3 negative counters. 1, 2, 3. And then we're going to add 4 more negative counters, 1, 2, 3, 4. And what does this give us at the end? Well, that's just 7 total negative counters on that. So this next example, again, we'll be using some counters on this, but on this one we do have some black counters because there's some positive values in this. And then we got the 9 negative values, right? So the 5 positive ones, 1, 2, 3, 4, 5. And then the 9 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, of course, we show any 0 pairs that would come from this combination. And I get these 5 0 pairs. So what are we left with? We got these 4, but those 4 are negative. So the answer to that one is negative 4. Alright, more number line stuff. On this one, we'll be starting at 5. Now, for this one, just right now, I know the minus says that we're going to go to the left. And we'll go to the left 11 spaces, right? So I'm going to tag some values, and you could do this. It doesn't really matter which way you do it. I'm just going to put some values, some more values on the number line. Alright, so starting at 5, I'm going to go to the left 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, there's 11 right there. And what value is that at the end? That's at negative 6. So this answer is negative 6. So this next number line, again, I'm going to start here at negative 3. And then the minus tells me again that I'm going to go to the left 4 spaces. So starting at negative 3, I go to the left 4. 1, 2, 3, 4, which appears to be at negative 7. So the answer to this one is negative 7. Alright, no number lines on this one. We'll just do the straight math. And again, if you wanted to look at this as negative 3 plus negative 11, you could, because we know the answer is going to be more negative, in which case you do 3 plus 11, which is 14. So the final answer on this one is negative 14. Same with this next problem. You could write it as negative 7,283 plus this negative 231, which again is going to show that our answer is more negative. But then I got to take those two values and add them together. So 7,283 plus 231. Again, we just need to remember that the answer is going to be negative. 3 plus 1 is 4. 8 plus 3 is 11. 1 plus 2 plus 2 is 5. And then we got the 7. So that's a negative 7,514 for this answer. On part C, I see a minus, a negative, so I'm just going to change that to a big plus sign, which really makes this negative 23 plus 9. Now on this one, I know I have more negatives, in which case I'm going to take the big number and subtract its opposite, in this case, which was the positive 9. And that would give me, should be 14 on that, so the answer to this one is negative 14. Next up, we have multiplication and division. Just remember, if there's an even number of negatives being multiplied, or divided for that matter, then the answer is a positive. If there's an odd number of negatives being multiplied or divided, the answer is a negative. So the first thing I would do on any of these is to determine if the answer is positive or negative. So the two negatives here, 2 is even, which makes our answer positive. Then 2 times 5 is 10. For part B, again, we got 2 negatives. 2 is even, so I know my answer is positive. And then I've got 173 multiplied by 3. So there's a 9, a 21. 3 times 1 is 3 plus 2 is 5. So positive 519. Next up, we got negative 20 divided by 2. There's one negative. 1 is odd, so I know my answer is negative. Then we do 20 divided by 2. 2 goes into 2 one time, so minus the 2 gives us a 0. And 2 will go into 2 zeros 0 times. So the answer, this one has 0 remaining, by the way. So the answer is negative 10. So this next one, we got 2 negatives. 2 is even, so we know the answer is a positive. Now again, that's nice because I get to ignore all the negatives. But we'll use some long division to figure this one out. So that looks like 16,107 divided by 7. Well, 7 won't go into 1, but it will go into 16 2 times. 2 times 7 is 14. Subtracting, I got the 2. So I'll drop the 1. 7 goes into 21 3 times. 3 times 7 is 21, which makes that a 0. Now it will go into this 0 in the tens place 0 times. And so we'll drop the 7. How many times does 7 go into 7? 1 time. So the final answer on this one, positive 2,301. Alright, for each of these, I'm going to actually expand these out so it's not in exponential form, but in repeated multiplication form. This should help us a little bit, okay? So I got negative 2, but multiplied by itself 3 times. So I do have these in parentheses because the negative was in the parentheses, and I got 3 of them, right? Now for this one, how many negatives do we got? 1, 2, 3 negatives. 3 is odd, so I know the answer is a negative. And then 2 times 2 times 2 is 8. So the answer to this one is negative 8. Next up, first I'm going to start with this negative on the outside, and then I would expand the negative 7 multiplied by itself, like this. So again, it's showing the 3 negatives, which makes the answer a negative, because that's an odd number of negatives. And 7 times 7 is 49. So the final answer to this one is negative 49. Alright, then we got a few application problems, such as Jim gained 7 pounds in January. In February, he lost 9 pounds. What was his net weight change in the 2-month period? So to start out with, he gained 7 pounds. So that's a positive 7 right there. But then in February, he's going to lose 9 pounds. So that would be shown as a negative 9 right there. And we're going to add these two together. So 7 plus negative 9, I've got more negatives than positives. And then, since they're opposites, I would subtract the 2. 9 minus 7 is 2. So negative 2, the negative shows that he would have lost. And how much? 2. But 2 what? 2 pounds. Alright, part B. A small plane descended 250 feet each minute for a 15-minute landing. What was the net change in the plane's altitude during that time? So a descension would indicate a negative value. So that's a negative 250 feet. But this is happening for 15 minutes, right? And this is for each minute. So if it's doing this for every minute, you could just subtract 250 from itself 15 times, but you could just multiply it by 15 because it's each minute for 15 minutes. Now looking at this one, I know that my answer is going to be negative because there's one negative and one is odd, so the answer is a negative. After that, it's just simple multiplication. 250 times 15. So 5 times 0 is 0, 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus the 2 is 12. Now I'm in the tens place, and it's just 1 times 250, which is 250. So I'm going to add these together. 0, 5, 7, 3. So this would be negative 3,750 as a math problem, but as a word problem, what is the change in altitude during that time? So again, the negative shows that it descended, and this is how far it descended, 3,750 feet. And that would be our final answer for this one. All right, part C. Jen wants to pay off her $2,000 debt equally over the next 10 months. How much money in debt will she be paying each month? So again, this is how much of something is in another thing, which makes this a division problem. And what are we dividing? Well, we're asking how many 10s go into 2,000 right here. So that would be 2,000 divided by the 10 payments, or the 10 months. So when we divide this, right, we got long division, which would be 2,000 divided by 10. Long division would look like this. And 10 will go into 20 2 times, so 2 times 10 is 20. And when we subtract this, we get zeros for all of the other remaining place values. So this ends up being $200 each month. So that would be our final answer right there, $200 each month. And that completes this worksheet, you guys. So thanks for watching. I hope this was helpful for you guys in preparing for the test. If you got any questions, let me know. And we'll see you guys in the next one.